Burning fat in order to lose weight is probably something all of us have thought about, or at least will think about at some point in our lives. And there seems to be endless debates on how to do it, with the best workouts, diets, and even fat burning zones. So what really is the best way to burn fat? Well, I'm going to say something that might sound a little bold, and that is, physiologically, there is only one way to burn fat. And this has to do with the body's energy systems and how the body metabolizes your macronutrients, which are proteins, carbs, and fats. So today, we'll talk about the only pathway that can metabolize fat and how this can influence the type of exercises you choose to most effectively burn fat. We'll of course review some of the different types of fat and how this influences health and weight loss, and at the end, we'll give some sample exercise protocols. We're going to get into some oily details in this one. So let's jump into this anatomical and physiological awesomeness. So let's quickly review some key facts about fat, because not all fat is the same. Plus, this will definitely help us to understand the mechanisms involved in losing fat. Most of what we deal with in adults is white adipose tissue or white fat. So if I use fat or adipose tissue interchangeably, just know that I'm talking about the same thing. But here's an example of this on the cadaver. And yes, it is more yellow on this cadaver. You can thank the embalming process for that, because in you, it would be more of a white to light yellow color. This white fat stores energy, provides padding and insulation, and can build up under the skin or around the organs, which means we can also subdivide fat by its location. Subcutaneous fat sits just under the skin, but on top of the muscles. And so it's what hides those abs and other muscles if it gets thick enough, because subcutaneous fat can be millimeters thick, like on this leg, or many centimeters or inches thick, like on this abdominal dissection. Then there's visceral fat, deeper inside, wrapping around organs like the heart, liver, and intestines. And this can also vary in thickness. On this body, you can see it is thinner and what would be considered at more of a healthy level. But on this body, you can see much more visceral fat and what would be considered an unhealthy amount. And the reason I say healthy versus unhealthy amount is because visceral fat is often referred to as the more dangerous fat, because excess amounts are more strongly linked to health issues like type 2 diabetes, heart disease, and high blood pressure. And studies also show it can ramp up inflammation and even mess with insulin sensitivity. And we'll kind of talk about whether or not you can target the loss of visceral fat versus subcutaneous fat a little bit later on. But there's also brown adipose tissue or brown fat, which is more common in babies, and it gets its color from being packed with specialized mitochondria and blood vessels. And unlike white fat, brown fat burns calories to actually generate heat. Now, adults do have some brown fat, mostly around the neck and upper back, and studies suggest cold exposure might boost it or activate those special mitochondria, which we cover in a lot more detail in our cold plunge video if you want to watch that afterwards. But now, we want to understand how adipose tissue behaves with weight gain and weight loss. Like what actually happens when the tissue gets thicker when we gain weight, and what happens when it gets thinner when we lose weight. Well, adipose tissue is actually classified as a connective tissue, made up of fat cells, and a loose network of collagen fibers dispersed between those fat cells. Now, the scientific term for fat cell is adipocyte. So again, if I say fat cell, adipocyte, or adipose cell throughout the rest of the video, we're talking about the same thing. But these cells are like little storage units packed with triglycerides. And a triglyceride is a molecule of glycerol bonded to 3 fatty acids. And if you were to gain weight in the form of fat, these cells would literally fill up with more triglycerides, which will cause the cells to get bigger. And as the cells continue to get bigger, this will cause the overall fatty tissue to get thicker. But let's say instead you were to lose weight from losing fat. And this often happens from calorie restriction, exercise, or a combination of the two. In those situations, signals would be sent to the fat cells, causing the cells to perform lipolysis. Lipo refers to fat and lysis refers to break down. So in this case, the triglycerides will be broken down and the fatty acids will be released from the fat cells. And outside the fat cells, there are also tiny blood vessels called capillaries that will take up the fatty acids. And once in the blood, that means the fatty acids could be transported to almost any cell throughout the body that might need the fatty acids for energy. And that could be a quad muscle that you were repetitively contracting during an exercise session. And if overall the fat cells release more fatty acids than they store, they will shrink. And as the cells continue to shrink, this will cause the tissue to get thinner and will make it easier for you to see those rippling muscles underneath. But let's come back to the part where we pulled the fatty acids out of the fat cells and into the bloodstream. Remember I said once in the blood, the fatty acids could go to almost any cell to supply those cells with energy. And this includes muscle cells, which are also often referred to as muscle fibers. However, I also said that there is only one way to burn those fatty acids. And this is where we get into the 3 energy systems of the human body. And with all this talk about burning fat and the different energy systems, some of you might be interested in tracking your calories in a very cool way. And that's where the sponsor of today's video comes in, CalAI. CalAI is an incredible app that makes calorie tracking a breeze. It's as easy as taking a picture. All you do is snap a picture of your meal, and CalAI will analyze the meal by calculating your calories and macros for you. Now, one of the things that turned me off from other calorie trackers is all the typing and searching that I was having to do just to find the right food. But with CalAI, you don't have to do any typing or searching, just seamless tracking. And from my experience, it's very accurate. But I always do make sure to check the ingredients after the scan to ensure the AI caught everything from the picture. And for those of you that want 100% accuracy, they also have a great barcode scanner and food database that you can use to double check. So if you're interested in dialing in your nutrition with less hassle, download the app in the App Store, Google Play Store, or simply click the link in the description and use my promo code IOHA for a 3-day free trial. Thanks to CalAI for supporting the channel, and now let's get back to the energy systems and burning fat. Going over these energy systems is going to help us understand why there's only one way to burn fat, at least metabolically. And this will also help us to choose exercises that could be more efficient at burning fat. Your body has 3 main energy systems to produce the energy currency of our cells called adenosine triphosphate, or ATP. And we produce the ATP from the energy primarily found in carbohydrates and fats. But we can also use proteins to produce ATP if needed, and also creatine gets involved. But here's the interesting thing. Only one of the 3 energy systems is capable of burning fat. The first energy system we'll mention is the creatine phosphate system, sometimes called the phosphocreatine system. This system is for super short, explosive, high-intensity efforts, like during the first 5 to 10 seconds of a sprint or a heavy set of low-rep squats. It uses stored creatine phosphate in your muscles to quickly regenerate ATP. And if you look at the diagram, creatine phosphate donates its phosphate to ADP with the help of an enzyme called creatine kinase to quickly form more ATP. The benefit of this system is that no oxygen is needed, and it's super fast. But the con is you can only store so much creatine phosphate in the muscles, so it runs out quickly, like in 5 to 10 seconds. But with creatine supplementation, you can store more creatine phosphate in the muscles and extend that time by a few seconds or so, which explains how creatine can improve performance. And there are more details on that in our creatine video that you're also more than welcome to watch. But notice, no fat is burned with this energy system. The next energy system is anaerobic glycolysis. Anaerobic means without oxygen, and glycolysis refers to the breakdown of glucose. This system kicks in for medium duration, high intensity activities, such as 10 to 120 seconds of all-out efforts or high intensity intervals. The benefit of this system is that it is also relatively fast at generating ATP. But without oxygen, the breakdown of one glucose molecule only produces a net of 2 ATP molecules. So eventually, in about 90 to 120 seconds, the 2 ATP molecules produced per glucose molecule just won't be enough for you to sustain that high intensity effort for much longer than 120 seconds, and you'll have to stop or at least slow down. Plus, a byproduct of this energy system is lactic acid, which quickly dissociates into lactate and a hydrogen ion. And those hydrogen ions can temporarily increase the acidity in the skeletal muscle fiber, also leading to fatigue. And like the creatine phosphate system, this system is not capable of burning fat. And finally, we have the third energy system, the aerobic energy system, sometimes also referred to as oxidative phosphorylation. Aerobic and oxidative both refer to the use of oxygen, and phosphorylation means adding a phosphate to ADP, adenosine diphosphate, to create more ATP, adenosine triphosphate. In other words, we are going to create a whole bunch of ATP from this aerobic energy system. And you could pretty much say that it's one of the main reasons why we breathe, because it doesn't just utilize oxygen, it also produces carbon dioxide as a byproduct. And this is the only energy system that can break down fats. So this might start getting you to think that certain forms of exercise might be better at stimulating this system and therefore better at burning fat. The aerobic energy system happens in the mitochondria of the cell and can actually use carbs, proteins, and fats as fuel to make more ATP. But again, it's the only pathway for burning fat. And the reason why fats can only be broken down by this energy system has to do with oxygen. Now, you can get into a ton of details as to why oxygen is needed to burn fat. And any of you who have ever had to memorize or learn beta oxidation, the Krebs cycle, and the electron transport chain know that it can quickly turn into a detailed mess. But for today's video, we will just say that fat breakdown, or lipolysis, releases fatty acids into your blood. And those fatty acids will eventually enter cells and muscle fibers that have mitochondria. These fatty acids then get shuttled into the mitochondria and go through a process called beta oxidation, where they're oxidized. And the products of beta oxidation, the acetyl-CoAs for you physiology nerds out there, are then funneled into the Krebs cycle, where they are further oxidized or burned with oxygen, which results in a ton of ATP. And I'll mention those ATP numbers in just a second. But without oxygen and this pathway, fats could not be used for energy. In some ways, you could argue that carbs are a little more versatile because carbs can be utilized in anaerobic glycolysis, and if there's enough oxygen present in the cell, some of the products of carbohydrate breakdown through glycolysis can be funneled into the mitochondria and make 30 to 32 ATP molecules per molecule of glucose. But that's nothing compared to the oxidation or breakdown of one fatty acid chain. For example, with a 16 carbon fatty acid like palmitate, the breakdown of this fatty acid produces about 113 ATP molecules. So you might initially think, wow, that's incredible. So why not always use fat if we can get over 113 ATP molecules per fatty acid? Well, just like the other two energy systems, there are some pros and cons. The pros of the aerobic system is the number of ATP you can get, and what seems like an almost limitless supply of energy, because 1 pound of fat packs about 3,500 calories. So a 180-pound person at 15% body fat has around 94,500 calories in reserve. But this system is slow. It takes many more steps, chemical compounds, and enzymes to generate ATP from fat as compared to the other two faster energy systems. And if we're talking about mobilizing the fat from adipose tissue in order to lose weight, then that takes even more time to pull those fatty acids from the fat cells, move them through the bloodstream, and into an exercising skeletal muscle fiber. Also, this system requires a lot of oxygen. At rest, this isn't a problem because our metabolic demand and therefore our demand for oxygen is low, and our heart and lungs have no problem supplying our cells with that amount of oxygen. This is even true with slight increases in demand with walking and maybe even light jogging. But as we increase the intensity of our activity during exercise, our demand for oxygen goes up, and then we are at the mercy of the cardiovascular and respiratory systems. Our lungs can only exchange so much oxygen and carbon dioxide. Our heart can only pump so much blood. Our blood can only deliver so much oxygen. So when we get to certain levels of higher intensity, we literally cannot get enough oxygen to the working muscles fast enough and don't have the time to utilize all the extra steps required to just burn fat. So we have to utilize carbohydrates as well as the other anaerobic energy systems such as the creatine phosphate system and anaerobic glycolysis. But here is something that's incredible. The level of intensity at where you start needing to cross over and rely on carbohydrates and those other anaerobic energy systems depends on your fitness level. As someone gets more fit, especially through aerobic training, the heart will get stronger and will be able to pump more blood. You'll increase the number of red blood cells. You'll increase the number of capillaries going to skeletal muscles, and you'll even increase your blood volume. All of this results in more oxygen being able to be delivered to an exercising skeletal muscle. So then you could stay within this aerobic energy system or this aerobic zone at a higher level of intensity before needing to start shifting to the anaerobic energy systems. Say, for example, when you were less fit, you could stay in this aerobic zone at 5 miles an hour on a treadmill. But as you got more fit, you could stay within this same zone at 6 miles per hour all because your cardiovascular system got better at delivering more oxygen to supply this aerobic energy system, and therefore is able to utilize more fat. And this finally gets us into the discussion of what is the best type of exercise to burn fat. Now, what's interesting about finding the best form of exercise to burn fat is that technically you burn the highest percentage of fat at rest, but percentage doesn't necessarily equal a high total amount of fat being burned. And to really understand why this is, I want to show you a chart that I love to reference from a case study of a male recreational athlete in his 40s who was training for a marathon, because this chart can really help to clear up some of the confusion around fat loss. So let's walk through what's actually happening here. On the left side, we have heart rate, which you can think of as a rough proxy for exercise intensity. As heart rate increases, you'll notice that the percentage of energy coming from fat goes down, while the percentage of energy coming from carbohydrates goes up. And this supports what we've actually talked about and learned today. Carbohydrates are simply just a faster fuel source, so as intensity rises, your body has to rely on carbs more heavily. But here's the key concept. Even though the percentage of fat being used is dropping, the total number of calories burned per minute is increasing. So if you look at the next column over showing fat calories burned per minute, fat oxidation actually increases as intensity rises, even though the percentage is lower, because that lower percentage is coming from a much larger total amount of calories being burned. But this increase in fat oxidation only occurs up to a point. In the case of this individual, it peaks around a heart rate of 130 beats per minute, and you can see that's the highest amount of fat oxidation at this heart rate. And this is what people refer to as the fat burning zone, or zone 2. And to be clear, this concept is rooted in real physiology. There really is an intensity where fat oxidation is maximized during exercise. But I do want to mention that your individual fat burning zone wouldn't necessarily be at 138 beats per minute. It depends on your age, fitness level, your resting heart rate, your max heart rate. But the overall pattern of this chart of percentages going down for fat and percentages of carbohydrates going up with exercise intensity, that overall pattern would be the same for you. It's just that maybe your fat burning zone might be in the 140s or the 120s. It is essentially what the fitness world refers to as zone 2 training, which is about 60 to 70% of your max heart rate. And if you know your resting and your max heart rate, there's a really cool website that can calculate all your heart rate zones that I'll link in the description. But this fat burning zone only tells us where fat burning peaks during the workout, not where fat loss is maximized over time. As intensity continues to rise past this point, yes, fat oxidation per minute starts to decline slightly, as you can see here. But the total calories being burned continues to climb. And this is where people can sometimes get tripped up. They see that the fat calories burned per minute are a little lower at the higher intensities, and then assume that the fat loss is going to be worse unless they scale back to that lower intensity of the fat burning zone. But that conclusion doesn't hold true once we zoom out beyond the exercise bout itself, because fat loss doesn't just happen minute by minute. It happens over hours, days, and weeks. So let's say instead of doing a 45-minute steady state zone 2 run or a zone 2 cycling session in this fat burning zone, that you did a 45-minute higher intensity steady state run or cycling session in zone 3 or zone 4. Even though the higher intensity exercise would burn less fat per minute during the exercise session, it would again burn a higher total of overall calories. And this creates a larger overall energy deficit and places greater recovery demands on the body. And when you recover, you're restoring ATP, resynthesizing phosphocreatine, reestablishing ion gradients, and replenishing glycogen. So you have this energy debt that needs to be repaid after exercise, and even between intervals that we'll get into in just a second. And some of this energy debt will get repaid from carbohydrates. But during recovery, a huge portion of that repayment comes from fat. So much so that in many cases, this can result in greater total fat oxidation over a 24-hour period compared to a lower intensity exercise session alone. So this also can apply to high intensity interval training. During a hard interval, which could be something that you could only do for 3 to 4 minutes, fat oxidation is relatively low. Or if they were really high intensity intervals that you could only do for like 30 to 90 seconds, which would go even beyond the intensity of this chart, fat oxidation would be even lower, almost even approaching zero in some cases. And so therefore, almost all of the energy would come from carbs through anaerobic glycolysis, with small contributions coming from phosphocreatine. And again, one might initially think this is a very inefficient way to burn fat. But between intervals, when you're recovering with walking or maybe jogging at a zone 2 intensity, what are you doing? You are breathing like crazy and very much using the aerobic energy system and fats to regenerate ATP, resynthesize phosphocreatine, reestablish ion gradients, etc. And so again, fat becomes an important fuel even with high intensity intervals. And this will also continue on after the whole workout is completed. So instead of asking, am I burning fat right this second during this exact bout of exercise? A better question might be, am I creating the conditions that allow my body to burn fat overall? And so the answer to this is burning a meaningful amount of total energy through the combination of different training intensities throughout the week. And the reason why the answer is not just do the highest exercise intensity you can do for every exercise session is because this often leads to burnout or overtraining. You can't just maintain extremely high levels of intensity session after session after session. Plus, there are still benefits to spending time in zone 2 or that fat burning zone. Even though technically you could burn a higher amount of fat at higher intensities, zone 2 still burns a decent amount of fat. And there are plenty of other benefits to spending some time each week in zone 2. And this includes the benefits it has in stimulating mitochondrial biosynthesis, which means the mitochondria you have get bigger and you create more of them, which has incredible metabolic benefits such as reducing your risk of type 2 diabetes, for example. Plus, it shifts the graph, meaning zone 2 trains your body to metabolize even more fats in that fat burning zone. So you'll start to see this number creep up at this same level of intensity. And this will also trickle into your overall fat burning capacity even when you're doing your higher intensity days. And we can't forget about the benefits of preserving muscle mass, which resistance training also is going to burn some calories, plus the benefits of increased strength, improved bone density, and even helping to keep your baseline energy needs a little higher. So if you've watched our channel before, you know that I tend to like a split that includes doing resistance training on, say, like Tuesdays, Thursdays, and Saturdays, where you alternate upper body days with lower body days, and then you could do cardiovascular training on Mondays, Wednesdays, and Fridays. And you could do all sorts of combinations of cardio training. I have some patients that like to alternate every cardio day, where one cardio day they do zone 2 and the next cardio day they do high intensity, and they keep flip-flopping. So one week they get 2 zone 2s in and 1 high intensity, and the next week it flip-flops. Or some like to do zone 2 on like Mondays and Wednesdays, and then go crazy with a high intensity day on Friday. And one of the beauties of exercise programming is that you can tweak so many different variables that can be tailored to a person's specific goals and can still be very beneficial for one's overall health. And we still have our sample workout chart that I can put a link for in the description if you want to check that out. But thank you so much for sticking around to the end of this video, everyone. I know we got into the physiological weeds a little bit, so hopefully you learned some very useful information, and let us know what you thought in the comments or any questions that you may have, because I still do actually read through the comments for feedback and new video ideas. And of course, we'll see you in the next video.